Module 5, Summarizing Data Graphical Presentation. Section number 2, Univariate Graphs. What does the term univariate means? As it says, univariate, only one variable taken at a time. So, the investigator considers only one variable at a time in univariate graphs or univariate analysis, you see. An example is the height of trees that we generated in the last section. More than two variables can also be plotted in such graphs, but the correlation or covariation or association is not what intended to convey. So, in that kind of graph it can also be called as univariate graph. So, other kind of graph is correlation or an association graph. So, that is will be covered in the next section, but in this section is more like a simple one variate graphs. So, there are several types of univariate graphs. So, when I tell you the term graph or chart or a plot, probably the thing come into your mind is all the univariate. For example, a bar, a pie graph, column scatter graph, Dynamite Plunger plot, Doughnut chart, Box-and-Whisker plot, line chart, area chart, and so on. So, there are several kinds of graphs. So, first of all, how do you present the categorical data? As I told you, it all depends on what the kind of graph to be chosen is depend on the level of measurement or the scale of the measurement. If it is nominal scale, then it is a categorical data that can only be labeled, you see. So, in that case, you have to use pie chart for the nominal, that is what people recommend, or you can even go for a bar chart as well for the nominal data. So, in general, if the wedge is to contain a percentage of the cases, then the angle of that wedge will be 360 multiplied by the angle alpha divided by 100. So, that will be the angle of that wedge. So, that it depends upon the alpha percentage. So, how much would that be? So, if you use pi, if you need to compare given category, the slice of pi to the total. So, part to the whole, if you want to compare it. For example, sex ratios of one state, you can compare that with a pie chart, the whole of which you are labeling the male or female. So, that is what the pie chart is used for, right. But if the alpha is very low, that means that multiple, for example, a sex ratio is 49 versus 51, and if you use that in the pi, then it is going to be tricky to understand 49.9 versus 51.1. It is not possible unless you have a protractor to measure the wedge size. So, it is not recommended to go for a pie chart in such cases. In the case of graph, the bar graph or bar chart is good for ordinal data. So, if you can categorize it, so if the level of measurement is ordinal, you can go for this ordinal data. So, meaning is assigned only to the heights of the bar, which represent the frequency or the relative frequency of the occurrence, right. The width contains no meaning, like histogram, the width has no meaning, but only the height makes sense here. Bar charts are good at ordering and comparing the data set. So, if you have multiple data set, you can compare that with the bar diagram. So, look at here in this diagram, you can see that there are actually pie chart here with labeled 5 categories, and there are 5 data sets, 3 data set, each has got 5 categories. So, it is almost impossible for you to know which of these is significant. For example, the green edge looks bigger in the first or the third or the second, no one knows it. So, just by looking this pie chart. The same categorical information we can also present by the bar chart. Now, it is a lot more obvious just by looking the heights of this bar. So, in a way, in a sense that the pie charts, rather than going for pie chart, it's always preferable to use bar chart. In my personal preference is that I will always go with the bar chart rather than the pie diagram, because pie is extremely confusing, especially if the wedge size are nearly similar. So, the bar graph is good for so comparing the data, especially the ordinal level, while the pie chart is good for comparing parts to the whole. But remember, if the two or more categories have similar range, then don't go for pie, but go for a bar diagram. So, the pie chart is for one series only and compare the contribution of different components part to the whole. So, one series different parts. For example, Indian population, which state contributes more, for example, or the languages in India, which language are being spoken quite often, or which is the least spoken language. So, all those things you can easily present it in a pie chart. Sometimes multiple chart forms can be combined into one. There is something called hybrid or blended chart forms. For example, in this diagram you can see the pie on the world map. So, for example, haplotype, the DNA haplotype types, Y haplotype or D haplotype or H haplotype. So, to see that, all you need to do is that you have to plot the pie into the world map to see the different haplotype common in those locations. So, it is very convenient way to visualize the data by combining more than one chart forms together. But my advice to you is, please avoid any unnecessary complications. Always remember Occam's razor concept. That is, actually the concept says that don't go for unnecessary complications. Simplicity is always preferred. For example, look at here, a 2-dimensional graph, you can easily convert that into 3 dimensions just by 1 or 2 clicks. It is very easy, anybody can do it. But 3-dimensional graph do not convey any meaningful information more than the 2-dimensional does. So, there is no point in going for this kind of 3D if the 2D itself is very good. Plain and simple is always nice, and more than that, if the black and white is fine, then why to go for a color graph? So, it is also again makes no sense. So, avoid all these unnecessary Vanity Fair complications too. So, Doughnut is a variant of the pie chart. So, instead of just one series, you can go for 2 or more series, like the Doughnut, arranged like in concentric circles. So, that is Doughnut chart is an example of a hybrid. Again, it is something like a pie, but more than one series you can do that with the Doughnut chart. Column and bar chart, as explained to you, bar chart is always preferred over the pie chart, as I told you that. So, column is usually vertical. So, that is what the column chart is, while bar chart is usually horizontal. Well, both are just same thing, just there are two terms, bar and column, but both are exactly same thing. There is another kind of chart is known as column scatter plot. In this one is basically a column chart, but instead of simple column, the column chart usually, if you summarize into a column, usually we summarize only the mean. For example, the body weights of 100 people in one location. So, if the mean weight is, let us say 45 kilogram, the bar chart will contain only 45 as a mean, right. So, there is no way that you can visualize the individual data set. So, if it is 100 or less than 100, it is always preferable to go for a column scatter plot that contains the column at the mean plus all the individual values that will be in the dots. So, it is like a scatter plot from the lowest till the highest, all the plots can be there in the column scatter. It is really convenient to see the dispersion. You can really visualize the data by looking at the column scatter plot, also known as dot plots. Another interesting plot is known as Dynamite Plunger plot. It looks like dynamite in a cartoon if you read some cartoons. So, you can see the dynamite is like that. So, it is like a bar with on the top there will be an error bar. It is actually coming out only in one direction, only on the top you can see that error bar. So, it also looks like a plunger. That is basically the French press for making home brewing the coffee. So, it is just like the press, you press that it looks like a plunger. So, that is why it is called Dynamite Plunger plot. So, this plot has mean plus or minus a standard deviation. So, we will see that the standard deviation in the later module, but that is how it works. So, it could be the error could be either standard deviation or it could be standard error of mean or 95% confidence interval, or it can be something else as well, like the quartile, like 75th quartile as well as 25th quartile. So, both will be unequally arranged, or it could be just the range, So, there are multiple ways to plot the error into the graph. So, here it's a special case of the column graph, the dynamite plunger with an error bar in it. This is another one, the column scatter plot with mean and standard deviation. So, this is basically the scatter plot with the column, and you are comparing, you are adding the mean and standard deviation. That is what the mean is the height of the column, and the error bar on both sides is nothing but standard deviation. And this column also contains individual the dots, you see the individual elements of the data set, all the elements have to be in it. So, this column scatter plot is preferred if your the element number of element or the size is less than 100. So, it can easily be plotted into this column scatter plot. Another example of a plot is known as box and whisker plot. So, box and whisker that will be covered more in depth in one of the later slides. So, this plot contains, there will be a rectangular box in the middle, and the box, one side of the box. So, box and whisker could either be vertically or horizontally. So, both ways are just fine. So, if it is in vertical size, so you can see one rectangle in the right and center with one line in between, in the middle. So, this line, it need not be in the middle. So, the line represents the median of the data set, because on the y axis you can see that this is nothing but marks obtained in a class. So, the median mark is that line indicates. So, this rectangular box have got two sides, upside and downside. Upside will be at 75th percentile, while lower side will be at 25th percentile. So, these are quartiles, two of the quartiles, and there will be error bar on the top as well as bottom. These are nothing but whisker, it looks like cat's whisker. So, these whiskers will project all the way up to the maximum value or the minimum value. So, both ways, so maximum to the minimum. Sometime the whiskers will project to the 90th percentile and 10th percentile, the highest value within 90th percentile or lowest value within 10th percentile. So, there are the multiple ways to draw the box and whisker plots. So, box and whisker is nothing but a 5-point summary or 5-number summary, the visual representation of the 5-number summary. What are these 5 numbers in it? Minimum, first quartile, median, third quartile, and maximum. So, visual display of this 5-number summary is nothing but box and whisker plot, or sometimes it's called box plot. It's a very good way to summarize your data set if it is having a lot of points, millions of data points. So, if the size is very high, just summarize that in box and whisker plot rather than simply going with mean or mean plus or minus standard deviation, which is highly confusing. It does not convey much information, but box and whisker do contain it. And more than that, box and whisker is a non-parametric method, because it is it does not actually make any explicit assumptions about the probability histogram from which it came from. So, box plot or box and whisker plot is useful for descriptive statistics. Sometimes the box and whisker plot also contains the individual values. So, that is also highly useful if you want to make if you want to summarize the finding, and you can also spot some outliers. So, remember the outliers will be covered in one of the next the future modules, but do not attempt to identify these outliers by looking and picking manually. So, that is highly problematic. Line chart is another way to visualize the data, especially for the time series. Usually the line charts have the x-axis some point of the time. For example, it could be years, or it could be hours. So, that is what the line charts are, and y-axis could be whatever the data that you would like to plot. For example, change in literacy rate over the years. So, it could be a good example for the line chart. Area chart is another way. It is just like the line chart, but the below point is now highlighted. So, the area under the line is now shaded with different colors. So, that is what it can also be stacked. Stacked means one over the other you can actually make into the area chart. So, it is just another form of the line chart. So, in summary, univariate graphs plot values of one variable at a time. Some common example of the univariate graphs are hybrid forms, univariate, as well as hybrid forms are bar graphs, column scatter graph, Dynamite, Plunger plot, pie chart, donut chart, column chart, box and whisker plots, line charts and area charts. A general rule of thumb while choosing an appropriate graph form is the Oxam's razor. Don't go for unnecessary complications if the simple illustrations can fulfill your whatever is in your mind to convey to the information, or however way to visually summarize your data set. Thank you so much for viewing this. I hope you liked this one, and I will see you in the next section.